Okay, I guess we can start now. So, I welcome you all to this talk on end-to-end testing of single-page applications with Protractor. I'm Fawad Rafi. I have been building single-page applications for over 8 years with a variety of frameworks such as pure JavaScript, jQuery, Angular, Backbone, and Polymer. In this talk, we will first talk about single-page applications and how these are different from traditional websites. Next, I will go over this tool, this really neat tool called Protractor that helps us test. Thank you. But from end-to-end testing of single-page applications seamlessly, we'll go over its API and some of the basics of this tool. I will show you some code examples and ways you can configure this tool to meet your to customize the tool to meet your needs. If you want to tailor the basic configuration, do advanced things, or use any frameworks of your own choice. And then we will take questions and answers and open up the floor for discussion. If you have any questions, please wait for towards the end of the talk, because I'll give you plenty of time to ask your questions. And if you have time towards the end of this talk, we will do a hands-on exercise and create some end-to-end tests for an application using Protractor. So a single-page application is fundamentally different from a traditional multi-page website. A traditional website is essentially a collection of static HTML pages and web forms. When a user visits a traditional website the very first time, the browser sends an HTTP GET request to the web server. The web server receives the request and responds with HTML sent back to the client or the browser. To interact with the website, the user has to navigate to a web form, fill in some data, and click a button. At this point, the browser will execute JavaScript to validate the user data. And if everything looks OK, it will send the data back to the web server. This could be an HTTP GET request with URL parameters, or if the data being sent is large, it could be an HTTP post with the data in the body of the request. Once again, the server will receive the request and send HTML back to the browser. This entire communication between the browser and the server is synchronous. From the time an HTTP request is sent to the server and an HTML response has been received by the browser, the user really can't interact with the website. When a complete HTML response has been received by the browser, if you have any state stored in JavaScript variables on the page, it has to be repopulated from the response. So eventually you lose state on the browser between form posts or reloads of the page. It eventually makes a traditional website a stateless application. The good thing is every page in the application has a unique URL, URL which can be bookmarked and accessed independently of the other pages in the site. Each page also has a distinct life cycle. It begins with an HTTP request being sent to the server, an HTML response received by the browser and loaded into the DOM on the browser. The browser really is responsible only for basic validation, but has to make a trip back to the server for any sophisticated processing or business logic. So naturally, the response time for any user actions is going to be slow, because the entire request has to be sent back to the server, processed and received back in as HTML from the server and load it into the DOM. A single page application, on the other hand, is essentially an application which lives only on one HTML page that contains multiple sections or divs. The first time a user visits a single page application, the browser sends an HTTP GET request to the server. Now the server packages all the scripts, CSS, and HTML content for the entire website into a single HTTP response and sends it back to the browser. So in a single page application, the entire page loads into the DOM exactly once. All subsequent user actions will result in partial updates to the DOM, which will happen quite frequently because you will have multiple user clicks or interaction with the page. Between these partial updates to the DOM, any state stored in JavaScript variables on the page will be preserved. This results in a high performance website and a rich user experience. So JavaScript really is a first-class citizen in a single page application. It is used quite pervasively for making server-side requests to the server asynchronously without freezing up the browser. It relies on promises which under the hood use callbacks and AJAX. Instead of returning an HTML response, the server sends back either JSON or XML data back to the browser. Eventually, the role of a server is reduced to that of an API or middleware. It's not a true web server in the sense of that it sends back HTML anymore. It's now purely serving up JSON and XML back to the browser. Since there's only one HTML page in a single page application, all hyperlinks or navigation links are fake links. Clicking these links will not take you to a new page. It'll just hide and show sections or divs on the same page. So how is a single page application really different from a traditional website? It all boils down to the user experience. In a single page application, the user does not have to wait for the DOM to reload before any mouse clicks or data entry. So essentially, the user activity and the server processing can continue in parallel. That's how you get the rich user experience and the high performance of the site. We have to, a single page application, it will immensely improve your response time and the fluency of the user experience. But we have to make some architectural trade-offs to accomplish this. Firstly, as I had already mentioned, there are no real hyperlinks in a single page application. All navigation links are implemented as routes. When you click these routes, sections or segments of the same page, same HTML page are displayed or hidden. This allows the application to avoid a postback or a new HTTP request when you click a link. Also, it lets the application preserve state of JavaScript variables on the page to achieve the fluency of the user experience. The back and the forward function buttons on the browser are not very useful in a single page application, because clicking these will navigate away from the application, so you actually move away from the application completely, which is why these buttons, which are very useful in a traditional website for navigation, are not that useful in a single page application. Similarly, the cancel button on a single page application loses most of its utility, because in a single page application, there's only one HTTP request that the user can control with the cancel button. It is the first visit to the page. All subsequent trips from the browser to the server are made programmatically through Ajax. These trips cannot be cancelled by the user by clicking the cancel button. So really, only the first trip to the web server can be cancelled by the user. Subsequent trips, they are done programmatically. So pretty much you can't cancel those using the cancel button. Typically, when you navigate away from a website in a traditional web page, the browser raises the before unload event. This means the DOM is about to be unloaded. So if you have any page-specific logic or cleanup to be done, this is the time to do that. But in a single page application, you really have one HTML page. So there will only be one before unload event, and that's when you navigate away from the application. So there really is you really have to rely on some other event mechanism to determine when the user is switching between views or divs on that page. Since in a single page application, views and pages are different. In a multiple page application, each view is a page, and you can determine when the life cycle of one page begins or ends. But in a single page application, a programmer will not know exactly when the life cycle of one view begins or ends. You really have to rely on some framework which you use to build the application with, to raise events to tell you when the user has switched between views on the application. Also, in a traditional website, when you visit the web page, you only need to download the scripts, CSS, and HTML for one page at a time, not the whole application. But in a single page application, the browser will not make subsequent trips to the web server to get the additional resources, which means on the first visit to the website, everything has to be uploaded to the browser. All scripts, all CSS, all the HTML for every view in the application has to be sent back from web server to the client in a single response. Now, considering the number of scripts you need for validation, routing, state management, and Ajax calls, we are talking of maybe 20 or more scripts. And depending on how complex your application is, these could be in megabytes. So the initial visit to the website in a single page application is going to be slower than the first visit to the page in a traditional website. Also, a single page application does not unload the content from DOM until the user navigates away from the application. This means any JavaScript variables on the page will remain in memory. Any background calls you make through HTTP will keep adding more state to the application. Now, JavaScript uses a non-generational mark and sweep garbage collector, so which makes it very easy for a programmer to inadvertently introduce a memory leak in a single page application than a traditional website. So you have to be very careful with your code because it will stay in memory for as long as you are on the website. It will stay in the DOM. Finally, each browser has this very useful loading message or a progress bar which it displays when it is waiting for an HTTP request to complete. This is a very powerful visual cue to the user. In a single page application, only the first visit to the website will benefit from this visual cue. If subsequently any HTTP calls made through Ajax take a very long time to complete or they fail completely, the browser will not automatically display any loading message or any status to indicate failure of these requests. So the programmer has to implement a custom message to indicate status of the request in a single page application. All of these things make, so while we get a lot of speed and performance with a single page application, these architectural trade-offs make it hard to test a single page application, which is why we need a tool that helps us do the testing with the minimum level of pain. So today we will talk about this tool called Protractor, which helps us perform end-to-end testing of single page applications. You can also use it for testing a traditional website, but the real power of this tool is when it's used for single page applications. Protractor is really a Node.js program. It's a end-to-end testing or a integration testing framework. I use the term integration testing and end-to-end testing interchangeably because they mean the same thing. You are treating the application as a black box and testing like a user, as opposed to testing individual components or classes. You're looking at the application as a whole. So the idea is, as applications grow in size, it becomes very unrealistic to rely on manual testing alone to catch regressions in existing code, to ensure the quality of new code, and to catch bugs. Typically, you will use unit tests as a first line of defense, but those are not useful in catching bugs which arise when you put together components and layers and different services together. Unit tests are great at catching bugs in individual functions, classes, components, or services. But when you put things together in a fully assembled application, a fully assembled environment, including front-end, back-end, middleware, and downstream services, those kinds of bugs are not easy to catch with unit tests. So to give you an example, end-to-end tests or integration tests will help you answer questions like, is my front-end code communicating with the middleware? Is the middleware code communicating with any downstream services or web services or your database or any other service which it has to interact with? Maybe if you have a layer of microservices, are those being invoked? Thirdly, is your application rejecting bad data? For example, if somebody is trying to use a test username and password in a production environment, is the application rejecting those and indicating some error back to the user? Fourthly, and most importantly, it indicates whether your application is ready for release at any time. That helps us gauge whether we are 30% complete or half complete, or are we 90% complete, and can we release it with known bugs or not. So eventually, to install Protractor, all you need to do is you need to install Node.js and you need a Java runtime. You need Java because Protractor is actually based on Selenium, and Selenium is a Java program. So once you have installed Node.js, you can use the Node package manager to install Protractor. This will install Protractor as well as install a bare bones version of Selenium that's compatible with your environment. Then you can use the WebDriver manager update to upgrade your version of Selenium to the most recent compatible version. It also downloads the Chrome driver. You just need two tools essentially to run tests in Protractor: Selenium and Chrome. The last command you only need to do when you want to run the test, that's when you want to launch Selenium. So this you will avoid right now. We'll do it when you actually want to run the tests themselves. But just to install this tool in your environment, you just need Protractor and need to update your drivers. Why would you use this tool? There are many good reasons for using Protractor. Firstly, it is now the official end-to-end testing framework or the integration testing framework for Angular 1.2 and later versions. The previous tool, known as Angular Scenario Runner, which was used for 1.0 version of Angular, that now has been deprecated. So even the Angular team is migrating their own integration tests from the Angular Scenario Runner to Protractor. The second reason is its open architecture. It leverages Selenium to give you full control over the browser configuration and to simulate user actions. You can also use this to run this in your tests in headless mode using Phantom.js. The third reason is that it uses a Jasmine framework. Now, most JavaScript developers are already familiar with Jasmine. They use it very pervasively for writing tests, for writing unit tests in collaboration with Karma. So if you already know Jasmine, you don't have to learn a new framework or syntax to write end-to-end tests, because this tool already uses the Jasmine framework for the tests. It's a Node.js program, so which means it's supported by a large developer community as well. And the last reason for using this is because if you write tests if you are trying to test an Angular application, the next step in your tests will be run automatically when the browser refreshes. So you don't really have to introduce any arbitrary sleep or wait in your code. Your test and the browser will be synchronized by default if you're testing an Angular application. So it works really well with Angular applications, and you get similar benefits if you're testing applications written in other frameworks. So Protractor actually is a great choice for testing single-page applications. However, we also have other tools which do the same thing. The most obvious one is Selenium WebDriver. It's been around for a lot longer than the rest of the tools, and it's, in fact, even Protractor uses Selenium under the hood. Nightwatch, Casper, and WebDriver IO are the other options that you can use. All of these tools are based on Node.js, and they let you run the tests in real browsers, as well as in Phantom.js for headless testing. Casper is the only exception to the rule. It currently only supports Slimer.js. This is not a real browser. It's a scriptable browser based on Firefox's Gecko engine. All these tools will allow you to run your tests asynchronously using promises. So here is an example of some configuration which you have to create. So before you write your first test, you have to tell Protractor which files to use for your specs or your tests, and whether you want to use a Chrome, Firefox, or IE for your tests, or Phantom. So we have just one file called the conf.js file, which is your primary configuration file for Protractor. This also serves as a configuration for Selenium. By default, when you run the WebDriver manager start command, it runs Selenium on port 4444. I don't think you'll have to change this. This can stay as it is. And then in line number 4, you can tell the tool which browser to use for the testing. You can use Chrome, Firefox, IE, Safari, Opera, or Phantom.js if you want to run this in headless mode. And line number 6, I tell this which file contains my tests, my integration tests. In line 7 through 9, I'm telling it to use the Jasmine format for reporting the test results, and you can use colors to improve the readability of the results. One of the best practices in Agile is to use continuous integration. And I'm sure Many of you already use that. So the idea is every time code is checked in, we perform a full build, including integration tests and unit tests. This ensures quality of the new code, prevents regression in the existing code, and will catch bugs too. It also helps us ensure that our code is ready to release and deploy at any time. So it improves it will reduce the time to market in that sense. Your code can be deployed as quickly as possible. There are two schools of thought about integration, about continuous integration. The first group, whom I call the classical automationists, they believe that automated tests should completely eliminate manual testing. They believe your test suite should contain not only integration tests and unit tests, but it should also include visual tests. Visual tests, they aim to ensure that your application runs, it appears uniform with the same colors, fonts, distribution of white space, and alignment of HTML elements across multiple browsers. If you adhere to this school of thought, you have to run your tests in a real browser. Now, running your tests in a single browser is slow. Running them in multiple browsers is going to be really, really slow. But the idea is that you can reduce, by doing that, you actually can eliminate dependency on key personnel and reduce the overall cost of ownership of your application in terms of extensibility and maintainability by relying completely on automated tests for your code base. So with Protractor, you can actually do this very simply by using the multi-capabilities property. This really is an array of key value pairs. Each key is actually a name value pair of the browser name, and you can indicate whether you want Firefox or Chrome. So the idea is when you use this property, all your tests will be run simultaneously in multiple browsers and give you complete testing, complete visual testing and integration testing in multiple browsers too. When you use this option, it will ignore the capabilities option. This one overrides the capabilities option. We also have a second school of thought about continuous integration. This group, which I call minimalists, believe that you should not try to automate, you shouldn't try to completely eliminate manual testing. Just write the minimal number of tests you need to pass 100% coverage of your code. So just try to write fast unit tests and integration tests. The faster your test suite is, the more likely your team is going to use the tests in their daily process. It will also mean your team will be more productive. If you adhere to this school of thought, you can simply run your tests in headless mode. This really means you are running the tests in a browser which does not have a graphical user interface. Since you don't have to repaint the window after every user action, these tests run exponentially faster than tests which run in a real browser. Tests which may take several hours to run in a Chrome or Firefox may run in a few minutes in Phantom.js, which is the most popular headless browser we have out there. All you have to do is use the capabilities option in your conf.js file and set it to Phantom.js. Most source code repositories support continuous integration out of the box. If you're using the on-premise version of Microsoft on-premise Team Foundation server, you can define a Windows build agent to run as a Windows service, and it will perform automatic builds when you check the code in. If you prefer the hosted version of Team Foundation server known as the Visual Studio Team Services, you can define a hosted build agent that does the same thing. In the open source world, GitHub and Bitbucket are the most popular repositories. There are several continuous integration services that blend with GitHub and Bitbucket. Jenkins is the top one. It's the most popular one. It is written entirely in Java and comprises a series of jobs. Each job is basically an automated build with a configuration file. It's a configuration XML file which you can use, which you can modify, and you can hook in Protractor over there to run your builds and include integration tests in the build. Travis is a crowd-funded tool that relies on, it has a YAML file, travis.yaml, which can actually be modified to integrate with Protractor. This works only currently with GitHub. If you want to use GitHub if you want to use GitHub or Bitbucket, you can use Circle CI. Circle CI works a lot like Travis, but it also has a YAML file, but it works very well with Bitbucket and GitHub. And then finally, I will mention BuildBot. BuildBot is based on Python, and this actually integrates with CVS, GitHub, Bitbucket, Perforce, SVN, and pretty much every repo out there. It has a lot of connectors for different repos. It's driven entirely by shell scripts. So all you have to do is install Protractor on your machine. Within your build environment, you can install Protractor and then write a shell command to run this in your build. If you're testing on a Unix-based environment and you want to use a headless browser, I would recommend using XVFB instead of Phantom. XVFB is the X virtual frame buffer. It is a display server based on the X11 protocol. With XVFB, you don't need any mouse or keyboard or a monitor to view the results. Essentially, if you use this, Protractor will kick off the results, the tests, and collect the results from XVFB. The idea is, so why would you use XVFB instead of Phantom.js? It depends on which version of Phantom you want to use. The first version, or in fact, most of the Phantom versions, 1.1 to 1.9, they use the WebKit browser engine under the hood. Unfortunately, the Phantom team kept using the same 2-year-old WebKit version, which crashes quite frequently during integration tests. But in January of this year, they released version 2.1 of Phantom.js, which has some patches which improve the stability of WebKit. So if you're using an older version of Phantom.js, it's likely you'll have more crashes in your tests, and you can use the XVFP instead. So let's look at some real tests over here. So in this example, I'm going to show you a basic test which tests for the application login. As you can see, the syntax looks a lot like Jasmine. It is, in fact, this really is Jasmine. It's using the same keyword, it's using the same idioms to describe tests, and then set up some expectations of elements. So in lines 3 through 7, I am browsing to the home page of the application or the root page, getting the current URL and saving it into a variable, then going to the login page, simulating user feedback. I mean, data entry by using the keyboard and sending the keys, typing in my username and password in the username and password fields on the page. In line number 8, I'm simulating a mouse click. And in line number 9, that's where I'm actually making an assertion. I'm expecting the browser URL to match the home URL after I have clicked the login button. If the login succeeded, both of these should be the same. So this is the basic structure of any unit test in Jasmine, and also the integration test in Protractor. We are setting up some variables and performing some user actions or keyboard actions, and finally we are setting up an expectation. If this fails, the whole test fails. So we save this in a file called mytest.js, and then use the Protractor command line from the terminal window to run the test. Here is the same example with some enhancements. Let's say we have a few variables which have to be shared across multiple tests. So to keep the code dry with less repetition and more reuse of variables, we can define the login URL and the home URL as inside the tests, and then we can populate these in a separate block. If you have used Jasmine, one thing which you will notice is that in Jasmine you have the before all and the before each functions that you can use to set up your tests and create some shared variable or shared state. We can't use those in Protractor, but we have a little hack that we can use over here. We can use it keyword that's used for tests and use it like a before all or a before each function. As long as we don't include an expect clause within this block, this will behave like a before all or before each function. So here I'm actually populating the variables login URL and the home URL. And then in lines 9 through 14, I am performing a test based on those variables. So we have this global variable called browser. This is a global object exposed by Protractor API that you can use to interact with your browser. Whether you want to send requests or read the URL, read cookies. So basically everything you want to do with the browser, like picking elements or doing any selects against the page source, you can do that using the browser global object. So that's how you basically construct your tests and then make them reusable. The idea is to use selectors or locators to pick elements from the HTML source and perform some user actions, and then expect something to happen to the website, and if it doesn't happen, we can mark that test as a failure or as a success. So what happens if your application or your test keep failing for some inexplicable reason? Now you don't know whether your source code is defective or you have written your tests the wrong way. In that case, you can use 5 tools to help debug the application or your tests. The first thing you can do is you can pause the browser at different points in your tests. This allows you to attach the browser's debugger. If you've used the Chrome DevTools or Firefox DevTools, there is a debugger which comes with the browser that you can use to attach code to your tests, not your source code, but your tests. So with this approach, you can only inspect the variables. You can actually halt execution of your test at any point in your test suite, and then you can execute the next command in your test, or you can evaluate expressions. Also, you can resume the execution of the whole test suite, but you cannot inspect your source code, your application source code. You can only debug your tests. If you are unable to resolve the issue using the browser pause function, you can use the node debugger, the Node.js debugger. Since Protractor is a node program, you can leverage the node's debugger to dig deeper into your application stack. And with that, you can actually inspect both the source code of your application and your tests. First, you have to run the application in debug mode. So you have to run the test in debug mode. We didn't use the debug parameter when you were running the test in the previous example, but now if you want to use the node debugger, you have to use the debug keyword over here in the command. This essentially instruments your application source code and the tests. And now you can step through the source code, inspect your promises, the browser states. Typically, you will use the pause function to identify the trouble spots in the application, and then use a debugger to drill deeper into those trouble spots and figure out whether it's an issue with the code or the test. You can also run Protractor in interactive mode. It's called Element Explorer. When you do this, it will not load your entire test suite into memory. It will allow you to pick any website, and then you can run your commands against that site. Eventually, it lets you test your Protractor commands, your selectors. It's like when you want to write tests, you want to first see which expressions to use, whether you want to use. You want to select elements by ID or CSS or XPath. You can use this mode to kind of pre-check your code, your test code. Also, you can take, when you are testing against a real browser like Chrome or Firefox, you can take screenshots of the browser and save it to the file system. So at the end of this slide deck, I have an example in the resource section which walks you through setting up your code to take screenshots of the browser. So if you want to use that, you please take a look at the end of this deck in the resource section. You can also write the console log of the browser to file system. This gives you more information which you can use to do root cause analysis. And to do that, you only have to first enable logging in the conf.js file for Protractor. And then you need to implement an after each function for Jasmine, which will flush your log so it can be written to the file system. So now we'll look at the API exposed by Protractor. If you have used Selenium or any tool like Cucumber, they all give you some functions which they maybe call locators or selectors to pick elements from the HTML page. We have the same API and same concept which is exposed by API in Protractor. So eventually, the first two are specific to Angular applications. If you have defined a model in your root scope in Angular and are binding it to a property in your HTML template, using the ng model directive, you can use the by model selector to pick any element which matches that property name. Similarly, if you use a Angular binding, the handlebar syntax over here, to bind a property in your Angular template using the ng bind directive, you can use that. You can use the by binding selector to pick elements which match that condition. You can also pick elements on the page using their title or the value. So if you have a button on your page, you can use the button text to do an exact match. So this will pick all elements which have the same text as save. We have a powerful partial button text locator as well. This is missing from Selenium. So this is something which you get only with Protractor. The idea is you can do a partial match. You don't have to have an exact match of the text. So if you have multiple buttons on this page, and this will pick all the buttons which contain the word save in the title. Now most APIs or most tools, they give you a CSS selector where you can use to pick items using a CSS property of which to match a certain style. We already have that, but we also have a deep CSS selector which lets you pick items from the shadow DOM. This is missing from other tools. So that's why if you use Protractor, you get some additional locators which will immensely simplify the task of writing tests and make your life much easier. And then we have the XPath and the ID ones. If you have a well-formed XHTML document, you can use XPath to pick your elements using XPath expressions. And ID one, this is pretty common. So we were seeing these functions, they let you pick one element at a time, but you can also pick multiple elements as a collection. If you are using the ng repeater from Angular, which is used commonly to render lists, you can use the by repeater selector in this API to pick all elements which match that. So this will pick the whole list, and then you can use so essentially by doing this you can return all the match element as an array or a collection, and then you can index through the collection by using either the get method or using user each method to loop through them as an array. In the previous page, you were using the element function to pick one thing at a time. So each of these can select both one element and a collection. So here on the next slide, I'm actually using the element all function to pick all elements and then treat them as a collection. So I can loop through them, or I can use indexer to go through these. Similarly, you can simulate the keyboard entry or mouse clicks on specific elements by first using a selector and then using either element all or element function to trigger events on specific elements in your page or the entire set of elements that match that filter. So like in this case, we are picking, since this is a 1 base index, it's not based on 0. So we are picking the second element in the matched element list and clicking it. And over here, we are sending the keyboard input. So hi followed by the enter key, sending that text to one element which matches the ng model directive in Angular. So I had already mentioned this, in the case of Angular, in this case of protractor, all tests are eventually run as promises. So you can actually write callbacks to resolve or reject a test, which is very useful if you are doing asynchronous programming. And then if you don't want to use Jasmine as your framework for writing the test, you can use Mocha and Chai, even Cucumber. All you have to do is you can use npm to install these frameworks, and then in the conf.js file, change the framework to Mocha. By default, it's Jasmine, but you can change it to Mocha as well. And then same thing for, since there is no built-in integration with Cucumber, you have to use a custom framework, and then that lets you define most of the configuration in the test itself. Okay, so if you have any questions, let's open up the floor for that. This can be a free-form discussion. If you have any questions, comments, if you've used this in the past, or you have used any of the tools for testing the applications, we can discuss that. Sure.
So if you're running a test and you're making like a call, click a button, and then an actual call out to get some data, go to a different view, it's going to wait for that automatically to finish before it expects the run the expected.
So is the application running, if you have applications based on Angular, or is this a regular website? So with Angular, if this was an Angular application and you had a long running, the question really is, if you have a long running task, you click a button and it's going to take some while to get some data and then refresh the browser. If this was written in Angular, you would use the wait for browser function. Sorry, it's called the wait for Angular function on the browser object, which will just automatically wait for it to refresh. The other option is actually, since it's based on a promise, you can write a promise, a callback, which will be called when the action resolves. So that's how you can, which means if you are writing tests for older versions of JavaScript, it will be a little hard. You may have to introduce a sleep interval over there. But if you're using a new version of Java which supports promises, then you don't have to, even if you don't use Angular, you can use promises to cache those kind of issues and re-execute tests. Okay, so if you have time, let's do a little demo. Since we only have about 6 minutes left, what I would recommend is we'll do a demo right now. But I have a GitHub, on my GitHub account over there, I have a sample application which you can test in Protractor. There is a to-do MVC application. It has multiple implementations in Backbone, Polymer, Angular, and Angular 2. So I actually cloned that application and then I modified that, so we can actually use that as our sample site to test. And then if you go to this URL, I have instructions on how you can install the application. So this is that URL, and it gives you instructions on how to set it up locally. You just need to have Python and a simple HTTP server installed. Once you have that, you can launch the application, and then for different, it has different implementations of the same website in Angular 1.1, 2.0, Backbone, React, and Polymer, and they have these relative URLs. So I already have installed this on my machine, and to give you an example, I'm going to now run switch over. Okay. So first I'm going to launch the browser. So first I will launch Selenium, and this is now running on port 4444 on my machine. Next I'm going to start the simple HTTP server, and now that's listening on port 8000. I can browse to, so on my local machine, on port 8000 I have the various examples for this running. I'll go to AngularJS. So essentially it's a to-do list. I can create tasks for myself. And then I can mark tasks, these tasks as complete, or I can even remove tasks. It's a simple to-do list. So we're going to test this with Protractor. Let me show you my conf.js file. So here in this file, I am using a single browser, Chrome. I have specified the file name which contains my specs. Let's give it a shot. So now it's going to launch the browser. Okay. And we get a neat little. So using Jasmine syntax, it's going to give me the green dots for every test which passed and tell me how long it took to run the whole test suite. And I will now run the same test in Protractor, in Phantom.js in headless mode. So now it's running the whole test again, no browser, just using Phantom, headless mode, same 7 tests. And hopefully it will take less time. Okay, so now it took about 14 seconds. It took about 30 seconds in the real browser. So this basically is how you use it to. I only did that was writing basic tests to see if the title is right. If I click one item, I should get one item back. If I create 2 items, I get 2 items back on the list. I can remove items. I can mark them as complete. That's basically what I was trying to demo. So the idea is you can use this tool to create some more confidence about your application, whether they are ready to release. And eventually, those challenges we have with testing of a single page application, we can automate the whole process. And whether you want to do it, you want to automate the whole test suite, including visual tests, or just you want to focus on your do a combination of headless testing and manual visual testing. Really up to you based on your team size and your timeline. But we have a great tool over here which we can use that. So I would recommend, if you have time, go back to this website which I have created for you, and you can use this to eventually do this whole hands-on testing on your own. Okay? Thank you. And I will share this slide deck on my GitHub account on the same link. So you can see the list of resources at the end, which have examples on how you can create tests with snapshot of the browser or write log file as well. Okay. Sure.